Hello everybody. In this video we are going to construct this little flip file about angle relationships. You need item 41 and it has 1, 2, 3, 4, 5, 6 pieces. So if you will go ahead and get those ready, you should have 6 of these that go with item 41. The blue one is just a title, so I'm just going to leave it alone. We'll use it when we glue these together. But let's take a look at this yellow one, the one about complementary angles. And here is the definition of a complementary angles. They add up, let me not write so darkly. They add up to 90 degrees. And the way I remembered this, I thought of the word complementary or complement and the word corner. And I knew that complementary angles make a corner. Both of those words start with a C. So that may help you to remember. I also want to call your attention to the spelling of complement. This is different than the word compliment, to say something nice about someone or to someone. If I say, that's a nice shirt, that's a compliment. That's a different spelling, okay? That spelling is, let me give you that one. Has nothing to do with math, but I want you to be proficient in your vocabulary. Compliment is a nice comment. So complementary angles, that's a different spelling than complementary, making nice comments. Okay, so complementary angles add up to 90. So let me show you an example of how this works. Let's draw some points on this corner. And let's call this point A, point B, and point C. So this is angle ABC. We could say that angle ABC is 90 degrees. Now, I want you to draw another ray for me. Let's put it right here. Let's bring it right out of B, something like that. It doesn't have to be perfect. And let's call this one point D. And I'm going to tell you that angle ABD is 35 degrees. So I'm telling you that this part right here, angle ABD, is 35 degrees. So what is the complement of 35 degrees? What is the measure of CBD? That's what we need to find out. So how would I find that? How would I find a complement for 35 degrees? It's basic math. 90 degrees minus 35 degrees is 55 degrees. So angle CBD is 55 degrees. So we would say that 35 degrees is the complement of 55 degrees. You could say it the other way too. You could say 55 degrees is the complement of 35. That would be fine. Complementary angles. Okay, the green part. Supplementary angles. These add up to 180 degrees. So let's take a look. I like to draw the vertex. That's always been a habit of mine. And let's lay some points in here so we can name our angles. So we stopped with D up there. Let's just pick up with E, F, G, and H. So I'm going to tell you that angle EFH is 180 degrees. It's a straight angle. So supplements are straight. Those both start with S, just like corner and complement, supplement and straight. We're working with 180 degrees. So what if I tell you that angle GFH is 50 degrees? So from G to F to H, that's right in here. That's acute. That's 50 degrees. And I want to know EFG. What's the supplement of 50 degrees? So I will say 180 minus 50. I can look at this and tell that it's obtuse. That's a big wide angle right there. And it is 130 degrees. So I would say that the supplement of 50 degrees is 130 degrees. Or vice versa, the supplement of 130 is 50. You can say it either way. So complementary, supplementary. Adjacent. Adjacent means joining or joined. They're touching. They're side by side. Okay. So let's look at this set of lines right here. And you notice I've drawn you a circle. There's a reason for that. I want you to put the vertex in. Make a big dot right there in the middle. Whoops, sorry. I was coloring away and it was on Shape Tool. Now, I want you to color these little acute angles with, I'm going to use blue. And then these big obtuse angles with red. Because this is going to help us figure out another relationship in just a minute. And I always tell my students to think of these as bow ties, like you would wear with a suit. You've got a blue bow tie here and you've got a red bow tie. And the two bow ties make a circle. They make that full circle. That's why I want you to see that big knot in the middle. So what we're saying, let's give them some dimensions just so that we can talk about them. I'm going to say that this is about a 30-degree angle. So to make the other part of that straight line, that would be 150 degrees. And here's 150 degrees and then 30 degrees. And that adds up to 360. That's my whole circle. So in these, adjacent angles are on different bow ties. In my color picture, red is adjacent to blue. Red doesn't touch red. It touches blue. So if you talk about this in angle terms, I would say that 150 is adjacent to 30. Or they could actually give our angles names. Let's see, we stopped with H up there. So let's make this angle I, angle J, angle K, and angle L. So I could say that angle I is adjacent to angle J and to angle L. We could say that angle K is adjacent, or it's joined to angle J and angle L. So adjacent means that they're touching, they're joined together. Adjacent angles. Complements are adjacent. Supplements are adjacent. They're joined together. Okay, moving on. We have vertical angles. So with vertical, these are sometimes called opposite. They are in the same bow tie. So let's color again. This is the same picture, so I'll just keep it the same. I've got my tiny little blue ones that we said are 30 degrees. And then I've got these big obtuse red ones. That would be, can you figure that out? If red and blue make supplements, and supplements mean 180. So 180 minus 30 is 150. And that is going to be true of the other half of this bow tie. Color really helps here. If you have some highlighters or colored pencils, draw your bow ties and that'll help you visualize. But put the knot in the middle. That'll really help you see the bow ties. So let's give these some names. I stopped with, which one? Sorry, JKL, so we're up to M. M, N, O, P, and I forgot to label O, is 150. So you have two bow ties here. That means you have two sets of vertical angles. You have angle M is vertical to angle O. And you have angle N that is vertical to angle P. And here is something that you need to know. This is one of those golden rules of math. Vertical angles are equal. Okay. They're in the same bow tie. Adjacent, different bow ties. Vertical, same bow tie, and therefore equal. Okay, one more, and that is called the linear pairs. And you notice that we have parallel lines, and there's a line running across those parallel lines. The line running across is called the transversal. That is this line right here. That's your transversal line. And these lines are parallel. Okay, so here is what I can tell you. First of all, let's label our angles. We have Q, R, S, T, U, V, W, X. And I'm not going to color bow ties this time. I'm just going to do the smaller ones. This will work just fine. So there's a black bow tie and a white bow tie. And down here we have a black bow tie and a white bow tie. Because on scrap paper at a test, you won't have colored pencils. So just use what you have. But you can see that each of these circles have a white bow tie and a black bow tie. So what if I tell you that angle R is worth 40 degrees? If I tell you that, you can tell me all the others. Because if R is 40, Q is 140. Those are supplements. 140 and 40, that's 180. If R is 40, T is 40. It's in the same bow tie. S would be 140 because it's in the same bow tie. The two bow ties together make 160 degrees. And let's just check that. I've got the white bow tie, and then I have the black bow tie. And that adds up to 360, a complete circle. Then all you have to do is copy that same circle down here. Because those lines are parallel. Any circle that I draw along that transversal will be just like these two. You could draw circles all day long, and you would get that same pattern all the way down. All right. So we can say that angle Q, angle S, angle U, and angle W all equal 140 degrees. That angle R, angle T, angle X, and angle V all equal 40 degrees. And that is an example of linear pairs. Okay, to assemble this picture, I'm going to take the vertical angles and put it on top of linear pairs. So it will sit something like that. Whoops, I don't know what happened there, but it did not like that at all. I'll tell you what, I'm not even going to try this. It shows you in the assembly video how to do this, so I won't even go there. If you need to, go back and watch your assembly video again. But when you get this stacked up, the angle relationships will be on the top. And you'll have a nice flip file. You can quiz yourself on what these mean. Okay, I'll see you in the next video for something entirely new, I think. And I hope you have a really good day. Bye-bye.